Hi, my name's Matt and I'm building a Sopwith Camel. This week I'm talking about destructive testing of wing ribs. I've not seen anybody else do this, so it's not a common thing anymore from what I can work out, but it was done back in the 1910s, 1917. So I talked through how I'm doing this, the maths behind it, and what I hope to achieve out of it. It's going to take me a few weeks to get the parts and things up and running before I can actually get a chance to do the test, but I'm quite looking forward to it. It should be a bit of fun. I'll see you on the other side. Time for an update. I've finished cutting all the 5mm ply and now got a new stack of ribs and they're coming along quite nicely. So what I've got here is these are 5mm ribs for ailerons, and there's a hole to be drilled in that for the support strengthening pipe, but I'll wait till I've got the pipe before I drill the hole. These are standard trailing edge ribs. These are the center rib, and these two are nose ribs, still yet to be done, but they should be straightforward. The first one, the stack here, is going to be identical to that. And the second stack will have a lightning hole there, and there's a tube to go through here for holding aileron controls and passing those through. So I'll knock those out when I get a chance. That's on the back burner now, because what I now want to focus on is destructive testing. And this will test more of my manufacturing skills, but it'll also test my manufacturing process and the quality of the work I'm producing. Ideally, a rib made out of these parts will hold about 80 kg worth of weight. So if it doesn't, I've got minor hiccups, although I can get away with down to 50 kgs, that's not desirable. So the next stage is to basically put a rib together with the various components, samples of the various components needed to achieve that. So, project for the next couple of weeks. What I'm showing here is a couple of pages from an aircraft maintenance manual dating back to the 30s called Brim and Boggis. These two pages are on testing wing ribs, basically destructive testing, and they're forming how I'm going to go about testing my ribs. The first page here, there's a little bit of waffle there, but essentially it talks you through how do you work out the weight that a single rib is required to carry. There's some sums there, but it basically boils down to work out the weight of the aircraft, work out the wing area of the aircraft, divide the weight by the wing area, and that gives you a figure per square foot in this case, because we're dealing with old aircraft and imperial measurements. Once you've got that, you can then work out how much space a rib is expected to carry. In the Camel, the ribs are separated by 11.5 inches, not all of them, but the main ones separated by 11.5 inches. The chord is 54 inches, which is the length of the rib from the nose to the tip of the tail. So multiply the two together to get your square footage. This brings us to a figure of 27 pounds per rib. Now the next thing you've got to work out is what your correct loading should be for that rib. 27 pounds is a rib carrying a 1G loading, which won't be sufficient to get it off the ground, of course, let alone doing anything like acrobatics or evading enemy aircraft. So you need to figure out what the loading requirement or what the safety factor is for that. This actually took quite a bit of doing, and ended up talking to a couple of guys online in order to figure out first what our best guess was, and eventually we found some documentation dating back to the 20s, which gave us a figure of 7. So our loading factor is going to be 7. This may change if we get more information. So this is research and on the go, so to speak. So a loading factor of 7 times 27 pounds gives us a test weight of 189 pounds or 86 kgs, which is basically the weight of a person standing on top of one of these ribs, which seems like a heck of a lot, but I'm not going to know until I actually do the test on it. So once we've got that, the next stage, if you look a little bit further down on this page, and you've got that triangle diagram. Now, what that relates to is the length is the chord, and it's broken up to 8 sections, A through to H. Section 3 and 4, C and D rather, form an apex of a triangle you raise above that. Now, the goal of this particular diagram is a way of working out how to spread that 86 kgs without using a lot of maths. So in effect, you draw this diagram on a very large sheet of paper, you make the area of the triangle 86. Then once you've drawn your various sections in, you basically count how many squares you've got in each section. Total squares should equal 86, and the squares in A should equal something, B should equal something, blah blah blah. I used a spreadsheet instead because I found that a little bit easier than drawing ginormous diagrams. So I've got my wing loading, and as you can imagine from the triangle here, the nose and the tail carries the least, and the centre of it carries the most. So once we've got that, moving on to page 2, and what we've got here is an example of a test rig. Now the first thing to notice is that the rib is actually upside down. It's upside down, and there's bags being strung from this test rib at each point of those 8 sections, centre point of those 8 sections. The rib itself is supported by the spars, which aren't shown, probably because they're obscured by the posts, but they're supported by the spars, and that's literally it. So with that, you load up the bags in proportion to the triangle, relating back to the triangle, and then once you've got that to a certain point, you then start adding more weight to each of those bags in proportion until the rib eventually collapses, which will be an interesting process. So where I'm at the moment is I'm currently making the remaining parts required to build up the rib, and for this we'll move on to the next picture. And this picture is a picture of the main plane long rib, which is the one that I'll be building. So here you'll recognise the various rib parts are made: the nose, the centrepiece and the tail. You'll probably, if you've been following me, you'll also recognise the front spar and the rear spar. I've recently made a nose piece for it, which is right at the very front, and the last piece I need is cap strips going top and bottom. They're a bit hard to discern on this diagram, but if it shows up on your screen, there's actually cap strips immediately above and below all the web ribs, and they go over the top of the spars. So I've got to construct those final few bits and pieces, then make a rib jig so that I can actually construct these ribs consistently, make one, break it, figure out where it breaks and what I need to change, then make another one. This could well be an iterative process while I try and work my way up to the required 86 kgs loading. I'd be very surprised if I get it first time. Hope you enjoyed that. If you're aware of anybody who's done this before or has put a video up on YouTube, please let me know. Just pop a note in the comments or what have you. I'll be really keen to take a look and see what I can learn from that. So look forward to seeing you next week. Cheers.